For as long as human beings have existed, the night sky has inspired questions that seem impossible to answer. Ancient civilizations looked toward the stars and saw patterns, stories, and signs from the heavens. Over time, those observations evolved into science, transforming curiosity into one of humanity's greatest pursuits: understanding the universe. Today, our view of the cosmos is vastly different from that of our ancestors. We know that Earth is only one planet orbiting an ordinary star. Our Sun is just one of hundreds of billions of stars within the Milky Way galaxy, and the Milky Way itself is only one galaxy among countless others scattered across the observable universe. Yet despite centuries of progress, some of the biggest questions remain unanswered. How did the universe begin? How did the first galaxies form? What is the nature of dark matter and dark energy? And perhaps most importantly, how much of reality remains hidden from our view? In recent years, astronomers have gained an extraordinary new tool in their search for answers: the James Webb Space Telescope. Built through decades of engineering and international collaboration, Webb represents one of the most ambitious scientific instruments ever created. Unlike traditional optical telescopes, Webb was designed primarily to observe infrared light. This capability allows it to detect some of the oldest and most distant signals in the universe. Because space itself is expanding, light traveling across billions of years becomes stretched into longer wavelengths. Objects that once emitted visible light can only be observed today in infrared. By capturing this ancient radiation, Webb effectively acts as a time machine. Every image it records reveals the universe as it existed long ago. Some of the galaxies it observes appear as they were more than 13 billion years in the past, when the cosmos was only a fraction of its current age. When Webb began scientific operations, expectations were already high. Astronomers hoped it would provide sharper images, more detailed measurements, and a deeper understanding of the early universe. What they discovered, however, proved even more fascinating. The telescope revealed galaxies that appeared surprisingly mature for their age. According to many existing models, the earliest galaxies should have been relatively small and chaotic. Scientists expected to see young systems slowly assembling themselves through mergers and gradual growth. Instead, some observations suggested the presence of galaxies that were brighter, more massive, and more organized than anticipated. This does not mean that current cosmological theories are wrong. The Big Bang model remains supported by a vast amount of evidence, including the cosmic microwave background, the abundance of light elements, and the observed expansion of the universe. However, Webb's findings suggest that the details of early galaxy formation may be more complicated than previously believed. Researchers are now exploring several possibilities. Perhaps stars formed more rapidly in the young universe than expected. Perhaps galaxies accumulated mass more efficiently. Or perhaps there are aspects of cosmic evolution that existing simulations have not yet fully captured. Whatever the explanation may be, these discoveries highlight an important truth about science: knowledge is constantly evolving. Every major breakthrough has the potential to reveal limitations in previous assumptions and inspire new investigations. To understand why Webb's observations are so important, it helps to consider the enormous scales involved. Light travels at approximately 300,000 kilometers per second. Even at this incredible speed, it takes more than 4 years for light from the nearest star system beyond our Sun to reach Earth. For galaxies located billions of light-years away, the journey takes billions of years. As light crosses these immense distances, it travels through an expanding universe. This expansion stretches the light's wavelength, a phenomenon known as redshift. The greater the redshift, the farther away an object generally is and the further back in time we are observing it. Redshift has become one of astronomy's most powerful tools. By measuring how much light has stretched, Scientists can estimate distances, reconstruct cosmic history, and track how the universe has changed over time. The James Webb Space Telescope was specifically designed to excel at this type of observation. Its instruments can detect faint infrared signals that would be invisible to many other observatories. As a result, it provides unprecedented insight into the universe's earliest epochs. Yet while Webb helps answer old questions, it also draws attention to even deeper mysteries. Among the most significant is the existence of dark matter. For decades, astronomers have observed that galaxies rotate in ways that cannot be explained by visible matter alone. The stars, gas, and dust that we can see do not provide enough gravitational pull to account for their motion. Something unseen appears to be influencing the behavior of galaxies across the cosmos. This invisible component has been given the name dark matter. Although it has never been directly observed, its gravitational effects can be measured throughout the universe. Scientists estimate that dark matter makes up roughly 27% of the cosmos. Even more mysterious is dark energy. In the late 20th century, astronomers made a surprising discovery while studying distant supernova explosions. Rather than slowing down due to gravity, the expansion of the universe was accelerating. Some unknown force appeared to be pushing space apart. This phenomenon became known as dark energy. Today, scientists estimate that dark energy accounts for nearly 70% of the universe's total energy content. Yet its true nature remains one of the greatest unsolved problems in modern physics. Together, dark matter and dark energy dominate the cosmos. Ordinary matter, the atoms that form stars, planets, oceans, and living organisms, accounts for only a small fraction of everything that exists. This realization has profoundly changed humanity's understanding of reality. Most of the universe consists of components that remain largely mysterious. The accelerating expansion of space also has remarkable consequences for the future. As galaxies move farther apart, some will eventually become unreachable. Their light will continue traveling through space, but future signals emitted from those regions may never reach us. Over unimaginable spans of time, entire portions of the universe could effectively disappear from view. This does not mean galaxies are physically vanishing. Instead, the expansion of space creates a cosmic horizon, a boundary beyond which information can no longer reach observers. If intelligent civilizations exist trillions of years in the future, they may see a dramatically different universe from the one we observe today. Many distant galaxies visible now could lie beyond their observable horizon. In this sense, humanity may live during a uniquely fortunate era of cosmic history. We possess the technology to study distant galaxies while they are still observable. We can investigate the structure of the universe on scales that may not always remain accessible. Perhaps that is what makes modern astronomy so extraordinary. The James Webb Space Telescope is not merely a scientific instrument. It represents humanity's desire to understand the unknown. Every image it sends back is more than a photograph. It is a message from the distant past, carrying information across billions of years of cosmic history. Each observation helps scientists reconstruct the story of how stars formed, how galaxies evolved, and how the universe became what it is today. At the same time, these discoveries remind us that our understanding remains incomplete. The cosmos continues to surprise us. New observations challenge expectations, reveal hidden complexity, and expose mysteries that previous generations could not have imagined. The universe is not a static backdrop. It is a dynamic and evolving system shaped by gravity, energy, time, and processes that operate on scales far beyond ordinary experience. As technology advances and future observatories join Webb in exploring the cosmos, humanity will continue pushing the boundaries of knowledge. New discoveries will emerge. Old assumptions will be tested. Some questions will be answered, while countless others will appear. That is the nature of exploration. The story of the universe is still being written, and we are only beginning to read its earliest chapters. Every distant galaxy, every faint signal, and every unexpected discovery adds another piece to an immense cosmic puzzle. And perhaps the greatest lesson of all is that the more we learn about the universe, the more extraordinary it becomes. Far from diminishing the mystery, each new discovery reveals how much remains unknown, inviting future generations to continue the search for answers among the stars.